Hi, and welcome to AP Chemistry Review. It's me, Dr. V, and I'm here to help you get ready for the AP Chemistry exam. It's always a good day to study chemistry. And what we're doing in this webcast today is we're going to go through free response question number 4 from the 2022 exam. This is a short free response question, and that means it's scored out of 4 points. Before we get started, go grab your calculator and your periodic table and your formula sheet if you don't already have them handy. What I recommend is that you let me introduce the problem and then pause the webcast, try to answer it on your own, and then listen to my explanation. I also encourage you to keep track of your own score as you go. Did you earn the point or points for that section or not? And what do you need to do to enhance your answer to make it really show your chemistry knowledge, which of course is the whole point of this. Question number 4 begins. Answer the following questions about the compounds NH2Cl and NCl3. The Lewis dot diagrams of the two compounds are shown. Part A says, calculate the number of moles of NH2Cl with a molar mass of 51.48 grams per mole present in 1.0 liters of a solution in which the concentration of NH2Cl is 0.0016 grams per liter. So really this is a stoichiometry problem. I want to know how many moles of this compound would be in 1 liter of solution. I'm told a mass per volume ratio. So for each liter of solution, I have 0.0016 grams of this compound. And then I know the molar mass, so I need to convert from grams to moles. And I get an answer of 0.000031 grams, so a very small mass. I do want to point out there are 2 sig figs given in the original concentration, and so I'm going to report my moles with 2 sig figs. This part of the question was worth 1 point. Either you had a correct setup with a correct answer, or you didn't. There really wasn't much wiggle room here. Part B continues, NH2Cl is highly soluble in water, whereas NCl3 is nearly insoluble. Explain this observation in terms of the types and relative strengths of the intermolecular forces between each of the solutes and water. In order to answer this question, we need to decide whether the molecules are polar or not. And when we do that, we really do need to consider the geometries. The molecules are not T-shaped, as you might infer from the Lewis structures. They're really a trigonal pyramidal geometry. If we think about electronegativity differences, for NH2Cl, the nitrogen-hydrogen bond is reasonably polar. The nitrogen-chlorine bond is a tiny bit polar. The electronegativities are actually very similar. And so we do have an overall net dipole for this molecule. If we look at NCl3, the NCl bond is a tiny bit polar, so I've got these little tiny vectors to represent that. And so we could argue that the molecule is a little bit polar as well. Both NCl3 and NH2Cl are polar molecules, and therefore we can claim that they can both participate in dipole-dipole attractions with water. Now, the NH2Cl molecule is more polar than the NCl3 molecule, and I would argue, therefore, that the attractions between NH2Cl and water are stronger than the attractions between NCl3 and water, even though they're both doing dipole-dipole attractions. If you have a more polar molecule, the Coulombic attractions would be stronger. NH2Cl must have the stronger intermolecular attractions with water because it's more soluble, which implies that the attractions are stronger. Now, this question's a little bit tricky because you could make the argument that NCl3 is actually not polar and that it could only do dipole-induced dipole attractions with water. If you decided to go that route, you need to make sure that your answer is consistent with that. You're still going to end up determining that the NH2Cl must have stronger intermolecular attractions than NCl3 with water. This question was scored out of 2 points. 1 point for saying that they're polar molecules and they can do dipole-dipole attractions with water, or an answer that's consistent with that. And the second point was saying that NH2Cl must have the stronger intermolecular attractions with water because it's more soluble, which implies the attractions are stronger. There's one last part to this question. The value of the enthalpy of vaporization for liquid nitrogen trichloride is 32.9 kilojoules per mole. For every mole of NCl3 that I want to vaporize, I need to put 32.9 kilojoules in. Calculate the amount of energy required to vaporize a 15.0 gram sample of NCl3. And they nicely gave us the molar mass of NCl3. All right, so what we need to do is do a grams to moles conversion and then use the enthalpy of vaporization to find the energy involved. I'm going to take my grams of NCl3, divide by the molar mass to get moles of NCl3, And I know for every mole of NCl3, it takes 32.9 kilojoules. And so I get an answer of 4.10 kilojoules. My answer should have 3 sig figs because I had 3 sig figs in my original math. And I do know the enthalpy of vaporization with 3 sig figs, so my answer should have 3 sig figs. And this was scored out of 1 point. You have a correct setup with a correct answer, or you don't. How did you do on this problem? The average score on this question in 2022 was 1.42 points out of 4, so about 35%, which is very typical, actually, for the short free response questions. So if you got 2 points or higher out of 4 in this question, you are doing well. If you found this video to be helpful, like the video and leave a comment, and don't forget to subscribe to my channel so you get all my latest updates, all my review materials, and you're ready for the AP exam. Remember, it's always a good day to study AP chemistry.